Hello everyone, I am Rupa Keswami, working as Assistant Professor in the Department of Electronics and Communication, SJBIT. I welcome you to Microprocessor Lab. In today's demonstration, we are going to study how LDR, relay, buzzer can be interfaced with 8086 trainer kit for controlling switch through light intensity. LDR is a light dependent resistance whose resistance varies based on the light intensity falling on it. Whenever there is dark, light intensity falling on LDR is low and resistance will be very much high. Whereas when it is bright, light intensity falling is high, resistance will be very much low. This is the principle of LDR. Buzzer and relay are the output devices which are controlled through our program. 8086 trainer kit used here as a central microprocessor 8086, which is a 16-bit microprocessor, and it has many peripheral devices, among which 8255 PPL, that is Programmable Peripheral Interface, is used here. Because 8255 supports 3 ports, port A, port B, port C, which are 8-bit ports, can be configured as either input or output through a control word register. We have a dedicated address to these. Port A addresses FFE0, port B FFE2, port C FFE4. Similarly, for a control word register, address is FFE6. Other than this, 8086 trainer kit also supports Windows and DOS packages, which helps us in serially communicating 8086 trainer kit with the PC, through which we can download our program onto 8086. Further, it is interconnected to our I/O devices. Coming to our program, it is LDR, where LDR kit is a I/O device which will be sending data to us and also receiving data to it. So LDR will sense light. When it is dark, through port A, we will be receiving value as 0. So when there is dark, LDR resistance is high and data sent is 0. Then we have to switch on our buzzer. So in our output, we have to observe that whenever there is dark, there is no light on LDR, buzzer is on. Whenever there is brightness on LDR, resistance is low, which will be sending port value as 1. Then we will be sending port C value as 00, which deactivates relay and switches off buzzer. So this is the principle of our experiment. Now we shall see how it is executed. So here, this is how the interfacing is done, connectivity. This is the I/O device, LDR device. This is LDR. This is buzzer. This is a relay. So this is the interfacing connectivity. Flat cable used to connect I/O device with the 8086 trainer kit. This is the 8086 trainer kit, which requires 5V power supply, which is supplied here, and it is connected to PC through our serial port. Now we shall execute the code. So before our execution, we have to create our own folder. Create folder by your name. To this, we have to copy some softwares, that is link 86, x8086, then edit. These are the 3 softwares required for us. Copy these folders, where edit is a software used to edit the program. X8086 is a software used to assemble, that is to convert our ASM file to object file. Link 86 is the software used to link our object file with the library file and to generate hexacode, which has to be downloaded onto our 8086 kit. Now open command prompt, go to start, run, type command cmd. Okay, it will open as command prompt. Here we have to go to our folder. Make sure where you are in by opening your folder. We are in administrator desktop name. Use command cd space desktop. You can use tab to get option with that spelling. Enter. cd space your folder name, enter. Here we have to edit our program. Right now I'll open the code we have already written. So edit ldr.asm is the file name given. You have to give path as ldr edit file name.asm, enter. Once we open editor window, we have to type the program. It's already typed here. I'll explain the logic of it. We have to originate from 2000h because till 2000h memories are dedicated for already designed functions. Then very first we are sending control word register as 90h, which configures port A as input and port C as output. Through port A we are reading the data. If brightness on LDR is I, then it will send the data as 1 through port A. Then we have to jump to this loop where we will be sending port C value as 00, which deactivates buzzer and relay. If data read through port A is 0, then it will go to next line where port C value is sent as 11, which activates relay and buzzer, makes beep sound. Once you type the program, go to file, save, exit from the editor window. Now we have to assemble the code by giving command x8086, give file name is ldr.asm, enter. Once program is assembled, it will give you lines assembled and error status. If there are no error, you can continue linking. If there are errors, you have to go to a particular line and debug. Then we have to link the program by giving command link 86, enter. Now we have to type file name, which is LDR. Don't give any extension, enter. Enter until you get a message saying it is linked. So now we have got a message saying that there is a exa file created. Now we have to download this program onto 8086 trainer kit. Go to start, programs. Here we have ESA trainer. Win86E is the supported tool. So if you have not switched on the power supply, you will get this error. Just say yes, give the baud rate and switch on the power supply. Make sure before you run this, your power supply is on. If not, you will get this message. Say OK. Now tool gets opened. Once tool is open, this is the interface where we have so many options to upload, download, then to view registers, memory, assemble, so many. Here we need to download our exa file. Click on download. Browse for exa file generated. Go to your folder. We have saved our program in interface folder. Open it. And there you have to choose the relevant exa file. We are running LDR. Choose ldr.exa file. Say open. Say OK. Then it starts downloading program onto our interfacing kit. Now we have to set our program counter. We have option here. Click on it. Remember we have typed program originating from 2000. So we have to give starting address as 2000. Say OK. Now program counter is set. Now we need to run the code. If we want, we have two options to run the code. It's a continuous run, or we can go to a command window. If you have any messages to be displayed, go to command window. If no messages to display, I can go with run program. Now since LDR doesn't have any message to display, I'll click on run. Once we run, you could see there is a high intensity falling on a LDR. It's making no beep sound. If I close it, there is a darkness, means there is no intensity on a LDR, hence buzzer is on. So this is how we will get the output. And with this, I hope you understood how the execution is done. Coming to its viva, you have to know the principle of LDR, that is light dependent resistor, then how it works, what is the resistance variation due to intensity and all, and what are the control word register format of 8255, how it works, what has to be given for what a configuration, so on. So I hope this video is helpful. Thank you.